Good morning friends. Welcome back to Parnika tutorials. In this video, I want to discuss about linked list in detail. So I request everyone to watch the complete video for better understanding. First, let me define an array. Then I will discuss the advantages and disadvantages of an array. So what is an array? Array is a collection of homogeneous elements. What is meant by homogeneous elements? You can store only similar type of elements. If you declare an integer array, you can store collection of integer constants. Similarly, if you declare a float array, you can store collection of real constants only. Now let me declare an integer array. So the data type is int and the name of the array is a and size here I am fixing it as 5. So this will say that what kind of elements you can store and what is the name of the array and what is the size. And you know that array's index will always start from 0 and go up to size minus 1. As the size is here 5, the index will go up to 4. Okay. And one more important property of the array is all the elements will be stored in contiguous memory locations. Let's assume that you are running this program on a 32-bit compiler. On a 32-bit compiler, one integer variable will occupy 4 bytes of memory. If one integer variable will occupy 4 bytes, 5 such integer variables will occupy 5 into 4, 20 bytes of memory. Okay, so let's take that the starting address is 100th byte. Now this integer variable will occupy 4 bytes. So from 100 to 103 bytes, this variable which is there at the index 0. Is it clear? Let's take that this is the index and this is the value. Okay, let's take that you are storing the value 10, 20, 30, 60, 70 like this. Are you able to understand? Now one integer variable which is 10 will occupy 4 bytes. So from 100 byte to 103. So however we will say the starting byte only 100 and this will be from 104 to 107. Then this will be 108 to 111, then 1112 to 1115 and 1116 to 1119. So totally 20 bytes of memory will be occupied for this array A. Now if you look at all the memory locations are contiguous. Is it clear? So this is the one of the advantage of the arrays. Now if I want to access one of the element, I can access randomly. How can I access the element? Suppose let's take that I want to access the element 30 which is there at the index 2. Then I can simply say array name and I can give the index. Then whatever the value which is there at the index 2, that value will be come. If you use the print of %d, the 30 will be displayed as an output. Are you able to understand? So the advantage of the arrays is they are contiguous locations. Is it clear? Means the memory will be, all the elements will be in contiguous locations and you can access any element randomly. Is it clear? Now let me discuss the drawbacks of the arrays. One is that they follows the static memory allocation. Is it clear? What is meant by static memory allocation? The memory will be allocated during the compile time. We have two types of memory allocation. One is the static memory allocation and another one is the dynamic memory allocation. Allocating the memory during the compile time we will call it as static memory allocation. Allocating the memory during the runtime we will call it as a dynamic memory allocation. The arrays uses the static memory allocation, meaning is that if you have declared an array called int a of 5, then 20 bytes of memory will be allocated if you run this program on a 32-bit compiler. Now let's take that while you are running the program, you want to store the 6th element. That is not possible because during the runtime we cannot allocate the memory. Similarly, let's take that you have declared an array of 100 size. Is it clear? Then totally how many bytes of memory will be required? If you are running this program on a 32-bit compiler, 400 bytes of memory will be required. And all these 400 bytes of memory should be contiguous. Is it clear? Remember that point. All these 400 bytes of memory should be contiguous. So one block of 400 bytes is required. Is it clear? Now let's take that you have asked the user to enter the elements. then user has entered only 10 elements. Okay, remaining 90 elements the user has not using. So 360 bytes of memory is wastage. Are you able to understand? So if you want to increase the size of the array during the runtime, it is not possible. If you want to decrease the size of the array, that is also not possible because it uses the static memory allocation. Are you able to understand? And one more drawback of the array is, suppose let's take that we have a size up to 5. Let's take that you have elements like this. Okay, at index 4 you have not inserted any element. Now what you want to do is that you want the like this 10, 20, 30, 40, 60 like this. Then meaning is that at index 0 you want 10, at index 1 you want 20, at index 2 you want 30, and index 3 you want 40. Okay, so this 60 should come here. Are you able to understand? So at a particular location, if you want to insert any element, meaning is that you should shift the remaining things. Are you able to understand? Suppose let's take the 20 is not there here, 30 is there. Now you want to add 20, okay, and you want to shift all of them. Then it is a very tedious task in the arrays because first thing you have to shift all these things, and at particular location you want to do it. So this is the one more drawback of the array. So what are the drawbacks is that wastage of the memory, which is the static memory allocation. Okay, and another thing is that if you want to insert any element in the middle or in any particular location, then you have to shift all the elements to the adjacent and then you have to fix it. So this is the advantages and disadvantages of an array. Then how can we overcome these drawbacks in the arrays? So one is the drawback of the array is static memory allocation. Then the developers have introduced a concept called dynamic memory allocation. As I said earlier, allocating the memory during the runtime, we will call it as dynamic memory allocation. Using the functions such as malloc, calloc, we can allocate the memory. Using the realloc, we can reallocate the memory also. Even we have a free function which is used to release the allocated memory. So either using malloc or calloc, we can allocate the memory dynamically. So during the runtime, if you want to allocate the memory, you can use these functions malloc and calloc. Okay, now using the dynamic memory allocation concept, the linked list nodes will be dynamically created. Now you can ask me, sir, if they are dynamically created, okay, now if they are dynamically created, let's take that you have created a node, okay, dynamically it is there in the 100th position, means in the 100th byte it is allocated. Now again you are creating the node dynamically, then at particular location, let's take that at 200 location, again it was allocated because we don't know at which memory allocation it will be done. Are you able to understand? Now from this node, if I want to go to this node, I should have the address of this node somewhere. Am I right or wrong? Because in the arrays they are contiguous location. If I know the base address, then I can easily find. Suppose if the base address I can access by using the array name, then if I want to go to a of 1, is it clear? Then I will write address of the array plus 1. Suppose let's take that address of the array is 100. Then if you add 1, then it will be 101. No, it is not correct because this is not the value. This is address. Then 1 into, you will multiply the size of the data type. If you are doing an integer in a 32-bit compiler, it will occupy 4 bytes. So in 104 memory location, the next element will be there. So if you know the base address of the array, you can easily find the address of any index of the array. But now as you are creating the nodes, okay, they are dynamically created, so they will not be allocated in a contiguous location. So if you want to access the next node, somewhere you should store the address of this next node. Am I right or wrong? So a node in the linked list will consist of two things. One is the data and another one is the address of the next node. Okay, if you are using a double linked list, then even it consists of address of previous node also. But first let me talk about the single linked list only. So in a single linked list, a node will consist of two things. One is the data and address of the next node. Now you can tell me the drawbacks of the linked list. What is the drawback? You want to store the data only, but however you are additionally storing the address of the next node, which is nothing but a pointer. So you want to store the data, but even you are storing the address of next node, which is nothing but you are allocating the memory for the pointer also. So let me discuss how to represent a linked list. So a linked list will be represented as a collection of nodes. So each node will have data and address of the next node. Okay, let me give it a simple example. I will create 3 nodes. Let's take that this is in 1000 memory location, this is in 2000, this is in some 100 location, just for your understanding. Okay, you have a data 10, you have data 20, you have data 30. Okay, now this is the first node. So how can you say this is the first node? Is that you will have a one more pointer called head, okay, which is pointing to the first node. So it will have the address of the first node. Okay, now this is the first node, this is the second node. So how can you say this is the second node? Address of this node 2000 will be stored here. Similarly, address of this node will be stored here. So this node is pointing to this node is pointing to this node. Now this is the last node. So this is the last node, meaning is that this is not pointing to any other node. So here you should maintain the value as null. So it is acting as a null pointer. Are you able to understand? Now let me discuss how can you define a node. As it consists of data and address, so it is having two different members. Am I right? So if you want to store different members or different data types, then you have to use the structures. So how can you define a structure? You have to use the keyword called strut and the name of the structure. Here the name of my structure is node. Okay, then I have to mention the members. One is that I want to store an integer, so I will write int data. Okay, and another one is that I want to store the address of next node. Remember this one. What is a pointer? Pointer is a variable which stores the address of another variable. If it is an integer pointer, then it can able to store the address of an integer variable. Similarly, a float pointer can able to store the address of a float variable. Now this pointer need to store the address of a node. So this pointer data type also should be a struct node. So if you write the data type of the pointer as struct node, then it can store the address of this node. So you can give your own name. You can give it as next or link or pointer, anything. You close the curly braces, you are closing the, means you are writing the semicolon. So this is the definition of a structure. If you define a structure, memory will not be allocated. You have to declare a variable, then only memory will be allocated. Is it clear? So this is the way the linked list will be represented. Now we will discuss the advantages of the linked list. One of the advantages of the linked list is that you can insert a node at any particular place. Suppose let's take that you want to insert a new node here. Then what you will do? You will create a node dynamically either using the malloc or calloc function, and you can assign some value. Then what you will do is that this node you want to keep in between. Then what you will do is that let's take that this address is 200. Then this node should point to this node. So what you will write here is address of the next node is 200. Then a link will be created to this one, to this one. Now this node address is 2000. Here you will store. So this node is connected to this one. So now without any big task, without traversing anything, you are able to add this node here. You are not shifting these nodes. Am I right? These nodes are there here, but you have added this node in between. Similarly, you can add a node at the beginning, you can add the node at the end. Is it clear? Without any shifting is not required. Are you able to understand? This is the one of the advantage, and another advantage is dynamic memory allocation. But what are the drawbacks of the linked list? One is the memory wastage. Is it clear? Because you are additionally storing the one pointer which is pointing to some node. So this pointer need to store the address. So extra memory is required. And another drawback of the linked list is that you cannot access any node randomly. Is it clear? Suppose if you want to access this node from starting node, you need to traverse up to this node. Then only you can access the either data or address of the next node. Whereas in the array, they are random. But in the linked list, they are sequential. You have to access the elements sequentially. And another drawback of the linked list is you can go in the forward direction. This is only limitation of the single linked list. Is it clear? Because you are maintaining the address of the next node. Is it clear? From this node, if you want to go, you don't know the address of this node, because suppose let's take that you don't have this one. Okay, let's make it simple. Here this is 2000. Okay, this is 2000 is there. So this connection is there. Now let's take that you are at this particular location. You have the address of the next node, but you don't have the address of the previous node. So you can do the forward movement only, but backward movement is not possible. That limitation, however, has been overcome in the double linked list. Meaning is that the double linked list will consist of three things. One is the data, address of the previous node, address of the next node. So you will maintain the address of the previous node here and data and address of the next node. So again you are storing a one more pointer, again wastage of memory. Is it clear? So I hope you have understood about the linked list. What are the advantages of array? What are the disadvantages of array? And advantages of linked list, disadvantages of linked list. In the next video, I will discuss about various types of linked list, such as single linked list, double linked list, single circular linked list, circular double linked list. All these things I will discuss in the next video. If you still have any doubts related to this video, feel free to ask me in the comment section. I will try to clear your doubts as early as possible. Thank you for watching the complete video. Have a nice day.